I've already mentioned sources and sinks and transports and how this relates to the divergence. So let me summarize this as follows. Generally speaking, we often think of vector fields as a transport phenomenon. Or we think of vector fields as a flow that, for example, may describe transport. For example, the velocity of water in a river may describe how the water is being transported there, obviously. But sometimes in a river you also got sources and sinks. In that case, the vector field that describes the transport or the velocity of the water will actually have non-zero divergence. We summarize it as follows. If the divergence is positive or negative, then the vector field has sources or sinks. In some sense, that captures the physical essence of the divergence. If we try to illustrate that with a few pictures, then I would do it like this. A source vector field prototypically looks like this. Here we've got positive divergence. A sink vector field generally looks like this. Here we've got a negative divergence. And we've already seen transport vector fields, which prototypically look like this. And here we've got vanishing divergence. For example, think of a river. You've got a flow vector field that describes the velocity of the river. And if you've got anywhere positive divergence of this flow vector field, it may describe that there's like a source of water somewhere. Maybe a natural source of water or an artificial source of water. Similarly, if anywhere the divergence is negative, then this will describe a sink of water. So somewhere water is being drained from the river at some point. Again, naturally or artificially. Typically in a river, the flow vector field will just have zero divergence. And of course, these things get a bit more complicated the physics model.